Let's talk about a revolutionary idea, one from Darius Alexander that proposes a whole new way of thinking about the number zero. It's a concept so fundamental it could potentially change everything we think we know about math, and maybe even the universe itself. So what really connects the farthest reaches of the cosmos with the tiny processor in our computers? And what if the key to unlocking reality is actually hidden inside a mathematical error we were all taught to avoid in school? Let's get ready for a journey that's going to challenge the very foundations of how we think.
Okay, let's dive right into a huge paradox. There's this deep, fundamental split between the logic of nature and the logic of our machines. On one side, we have a gravitational singularity, which is pretty much a physical case of dividing by zero. And the thing is, the universe just keeps on trucking. But on the other hand, if we try that same operation in a computer, we get a critical error. The whole system just halts. Why is that?
Well, the author of this concept suggests the answer lies in the very language we use to describe the world, specifically in how we treat the idea of nothing. Our classical zero is basically an informational black hole. Multiply any number by it, and all the information about that number just vanishes. It's gone, forever.
Trace arithmetic, however, introduces a completely different idea. Trace zero, or 00x. That little x symbolizes the potential that's held within the emptiness. It's not just nothingness anymore. It's a structure, a space that's ready to accept information. Think of it like holes in Swiss cheese. A small hole and a big hole both have zero cheese in them, right? But their potential to be filled is totally different. Classical math completely misses this distinction. Trace arithmetic, on the other hand, remembers the potential of that void.
So, with this new definition of zero, we can start to break the old rules. Let's see how things work in a world where nothing suddenly begins to matter. In classical math, dividing some number a by zero is just an error. Game over. But in trace arithmetic, it's a transformation. The number isn't lost, it's just compressed into this new form, a00x.
But here's where it gets really interesting. What happens when we multiply two voids together? Normally, that gives us, well, nothing. But here, it creates something real, the number 1. This is the big aha moment, the key equation. Two potentials, two shadows, can interact to create an actual material value. It's almost like a key fitting perfectly into its lock.
Okay, so now that we've got these powerful new mathematical tools, we can start to look at physics from a completely different angle.
So in this new model, gravity isn't some mysterious force pulling things together. Nope, it's just a natural result of geometry. Matter is simply what happens when these holes in space-time get filled. And these holes, these 00x structures, have a natural tendency to merge, which is what we experience as gravitational attraction. And maybe the most astonishing thing of all is that some of the most fundamental physical phenomena can be described by incredibly simple trace operations. Adding traces together, that's gravity. Multiplying them, that's the creation of matter. And subtracting them gives us radioactive decay. It's an incredibly elegant and simple system.
All right, let's bring it down from those cosmic heights and see how this could work on a much more practical level. For starters, what would a computer that can actually divide by zero even look like?
Well, the solution is something called a tibit, or a trace bit. It's basically a simple switch. In one state, let's call it 0, the number is material. It actually affects the physical world. But in the other state, 1, it becomes a trace, kind of a ghost in the machine. The computer can operate on it freely without any risk of error, giving it something that's almost like a digital imagination. This completely flips the programming paradigm on its head. Instead of writing defensive code, which is loaded with checks to prevent errors, we get offensive code. The computer doesn't stop when it hits an error. It treats it as a totally legal operation. It just shifts into a trace state, keeps on calculating, and then materializes the result as soon as the math allows it to. And all of this leads us to a truly fascinating hypothesis. What if this isn't some revolutionary new invention at all? What if it's actually the rediscovery of a principle that's already operating in the most advanced computing machine we know of?
Let's take a look at a synapse in our brain. That little gap between neurons isn't a flaw in the system, it's a key feature. This is the spot where an electrical impulse, which is matter, transforms into a chemical potential, a trace, before it rematerializes on the other side. It seems the brain is already a biological trace computer.
This would finally explain a very old paradox. How is it possible that the human brain, with all of its immense computational power, consumes only about as much energy as a small light bulb? The answer is surprisingly simple. Most of our thinking happens in this trace state, which consumes practically no energy at all. Power is only really drawn at the moment of materialization, when a thought becomes a decision or it turns into a physical action.
And so we come all the way back to that one incredibly simple equation. We've gone from abstract mathematics, through the physics of the entire cosmos, all the way to the biology of our own brains.
And this one simple rule seems to describe the fundamental mechanism of creation itself, that magical act where potential finally becomes reality. By just changing our view of emptiness, of nothingness, we might not only describe the universe better, but we could also create technologies that mimic its resilience and creativity in a much deeper, more elegant way.
And that leaves us with a final question to think about. Are we just inventing a new form of mathematics? Or are we on the verge of rediscovering one of nature's oldest and most fundamental secrets?